How's it going, everyone? Eulier Gonzalez, but this time is take a look looking at the front end system design. Why is this? This is a course taught by Evney Ray, but the whole point of this is that for UI developers or specialists, which is those who use now, for example, any JavaScript framework that allows to us to write any performant user interface. Okay. The idea here is that it is important to understand is the fundamentals as a way to or it is important to understand is the fundamental of system designs to build complex large scale applications. Why this is important? To understand this fundamental of the system designs to build a complex large scale application. As a UI specialist, that's what it'll be. That's what most of our companies are looking for. Can you actually build as a system, or can you now understand is the system? Can you build? Can you build a systems that are now capable to face and deal with user interactions? Are you capable to doing that? So for example, here, this is a user interaction. This is something that was designed from that. In this case, the word here is like you have all of these particular components, all right? Each one of these buttons, and it is important to. This is just an example. So for example, canvas is another way, all right? Canvas is another example. Here, this is quite different. The things or the buttons or the options, the feature that as a user I can interact with. All right. So with Word or with Canvas or followed by any other interface. So for example, let's say YouTube as a way to now show content to that. You know, as you can see, each one of them actually is after all, each one of them actually provide now a particularly designed here to solve a specific problem. Again, why this is important? Because especially if you're going to provide your abilities or your workforce, your labor to any of these companies as a way to solve a specific needs, especially as a UI specialist, it is important to understand how all of these things work. The fundamental of system UI as a way to build now more complex scale applications. So the case of Evney Rai is quite interesting because he works at JetBrains, okay? And JetBrains is quite interesting. This is a exactly, and this is in Spanish. All right. So this is the visual. This is now a text editor that you can use here for any of the thing that you might think about. But again, this is the integrated development environments that we can now as a developers getting here. And because he worked at JetBrains for over 3 years, it's actually quite interesting because if you take a look now at the interface here, if you're building this particularly, let's gonna stick with this. If you're building now this particularly user interface, right? What is this? No, just only this particular interface. If you're building this particular interface, as you can see here, similar as the YouTube or any content consuming or Canvas or for text-based content. So text-based context, image-based context, video content, and also for environments here like text editor content. It's like each one of them has a specific use case that allow you to do. And I think this is something interesting because my project will be is to build now a user interface or clone that user interface. My project will be is to clone a particular user interface, deploy that as a way to now see how you can is resize components. So image logo, image logo generator for that. There is a tons of that in the hackers. Not quite sure what actually is that specific tool. Logo maker. So for example, is this one? I think it's logo maker, right? But you need to actually get in there. That's interesting. It's like, well, but the idea is that is to actually understand is what are the fundamentals here. Is to understand is the fundamental of how these things work. Why is this? Because again, if you're going to provide your service as a way to help another company to build a particular user interface, for to cover is let's say a back office applications, admin dashboard, and the kind of thing, chat application is like, all right, you need to learn the fundamentals. One, you need to also need how to describe that in the most fast, precise way. And that's the reason of today's video. So let's go to actually is briefly describe is what is this course about and the core concepts for UI specialists. So because in this course we're gonna see is like, well, how now the browser works. It's important, especially because you're building this user interface on top of that. And if you're gonna use React, you need to also understand now how React works. Okay, the DOM API, which is pretty much like a shovel, where you're gonna find some elements. The Observer API, which is now this particular tool or API that allows us to build now more complex and common user interface, such as virtual lists. Something that you're gonna see a lot of the time, especially on e-commerce or any other place where you actually need to render several elements, and how you can do that in the most performant ways, or using now is this built-in tool. The other is that application state patterns as a way to actually how you can store is the state of your applications and how you can communicate through your applications, looking at the networking patterns. And last but not least is actually is design is this particularly feature. So we're gonna build is a social media feeds, all right, as a way to understand is that, okay, what is the kind of content that we want to show, unlike Word or Google Docs, where the main idea is to actually is show text-based context. In the case of Canvas is image-based context. YouTube is image and video content. So all of this is just to cover those most common use case as it is. Wait, what? Anyway, I'm not gonna fall for that trap. So, yeah, as a way to understand what is the introduction here, and then the core fundamentals, which is something that we're gonna do in today's video. All right. So the idea here is that it is important as a UI specialist, how we're gonna do our works and how we're gonna solve our problems. Remember, and I know I'm quite stubborn and repeated myself, and not following is the don't repeat yourself. The try, but in this case, is quite important for me and for the audience, since it is important to remember what we're gonna do as a UI developers. Build not only user interface but also design systems. And yes, because of that, it is important to understand if we're gonna build something, we need to know is how that thing works. All right. Uh, this is true also for performance. If you want to know how, if you want to optimize something, you need to know how that thing works. So for example, in the case of your motorcycle, so how you can actually is gain the most benefit out of this, uh, in terms of fuel, or in terms of gas, electricity, avoid brakes, clutch, how you can preserve your clutch as much as possible, and that kind of thing, you know. How you can use it also the dynamic, or the aerodynamic as a way to use that to avoid use the brakes, and that kind of thing. So again, it is important to understand how that thing works so you can now is see how you can optimize. And when you do that, you started to realize there is something beautiful and inspirational in that. It's like, because efficiency and effectiveness is something that generate in us an emotion that is this motion of being fluid, all right, or that we can solve all of these problems very quickly. That's exactly what we're gonna do here, by looking at the front-end design system, because you can also have is the back-end design systems, and again this goes beyond the scope of the work, but it's important to understand that. So in the design systems or in any applications, you can split that into three phases according to EFD Ray, right? This software engineer that works over 3 years at JetBrains and also at, at Meta. So for IFNI, it say, well, it is made this any application software. It is made so it is front end, it is API, as well as the backend. And in our particular case, because we are going to look at the front end design systems, for the front end, it is made of, well, first is the API communication, or how now you're going to communicate to the API. That's one. And then how you're going to now manage that data from the server on the client or on the front end. So the state management. And also how you're gonna now build and design some interface, okay, or interface interaction. Okay, how do we handle complex user interactions by showing thousands of elements in a small screen, for example, okay, and then the asset management. So this is now fields in which we are going, of course, diving into each one of them, but as a way to stick with this momentaneously, and then we're going to develop more in. So we're gonna name. So then we're gonna go in depth on each one of those topics. So, but we got the application, where in every application you have now of it is made of the backend, the API, and the frontend. For case the frontend, as a UA specialist, we care about is the API communication. Is that how we going to communicate with our API? Which protocols are we gonna use for communicating to our API to cover a specific part of this several features that we can provide here? Okay, how we gonna communicate to our API? How we gonna manage the states here at the client side, okay, uh, and how do we manage things like how do we store and manage data from the server in an effective and efficient way. Now this, it makes sense, for example, like normalized data normalization. It makes a ton of sense. It makes a ton of sense. Completely. It makes a ton of sense. So yeah, it's a data management. Okay, so how we going to now retrieve, store the data from the server in the most performing and efficient way. Okay, and then how we going to design is complex user interactions here. For example, complex user interactions like in this case, like hey, showing a menu here, as well as showing this menu as we hover on each one of those elements. How can we now showing a drawer here? All right, how can we close that drawer, and so on and so forth. Okay, so how can we now design this complex UI, okay, in our applications, and then how can we make to load all of those assets in the most performant way possible. Okay, to keep a healthy web vitals metrics. Here is this GSX, CSS, HTMLs, image, fonts, you name it. So all right. So and because of that, so the core of this is, remember, is for UI specialists, which is in our case. That's what I'm going to dedicate. That's the service, that's the business I'm going to provide to others. Okay, so the core fundamentals, and then the dog API, web APIs for complex UI patterns. So virtualization is a way to see what is the most, what is the what to see what one of the most commons of those UI patterns. So virtualization, application state design, the network and web application performance, and last but not least, the bonus section is a way to see now how you can actually design is how you can design is a state management, a in this case a front-end design system. Okay, this is something interesting because a lot of those companies out there are actually looking at this. It's like, I don't care about how many years you have with JavaScript, with TypeScript, with React, with all of these specific things. At the end of the day, we want is to build something. And I think this is when again, this is when things can get tricky, because most of the time it's gonna depend on you, on how well motivated are you, especially as a way to build that. What is the end goal of building that? But remember that after all, that's exactly what we're doing. And this is the business model as a developers, or at least as the UI developers. Okay, this is one particularly application. Yep, this is one particularly. This is a business, man. After all, this is a business. So which one of this you choose? In my case, as a UI specialist, all right. There's a lot of people out there that is saying, "Hey, yeah, but we need is a full stack, and here and there and over there, and that kind of thing." It's like, okay, chill. First as a UI specialist, and then we can migrate to become a full stack developer for that. So that role is going to eventually merge that. So yeah. So first, understanding is the core fundamental is that now how the browser treat the HTML, and how now is, because of that, how now the stacking context is connected to the formatting context, and how such context, the stacking context, is connecting to the GPU and the browser rendering cycles as a way to understand a little bit more, and the composition layer and how we can use the GPU to optimize the rendering, right? And then we're gonna see is the DOM API is like a shovel, where we need to know how to work with this API and modify the DOM tree. As I mentioned, Web API complex UI, virtualizations, network, web performance, or aka the asset management, and last but not least is the system design socially fit. All right, so let's get into this. So first thing first, it's important to know how the browser, especially as a UI developer or a specialist, how the browser sees or represent is these elements. So that's why we look at the box model and the box anatomy. So because in CSS, which is the way of how you can now provide all of this style as a user, as a UI specialist, okay? Well, everything in CSS has a box around it. Why is this? Because once you understand how this box works, and also how now but once you understand how this box works and how they interact with other elements, it allows you to build now more complex user interface. That's one. And second, it also lay out the fundamental step to build now more complex UI patterns, for complex UI layouts to complex UI patterns. All right, so we understand that the box anatomy, this is made of the content, the padding, the margin, the border, and the margin, okay? And how now this box have properties, whether it is the property of these boxes is by it is size and the type, all right? And by the size is and it is type is by saying, hey, is this box size is okay, is this box size is intrinsic or restrict? And by that is well, and I think this is quite interesting. Again, all of this is as a way to develop this narrative around this, okay? So because now all of these boxes have properties, so you have now the box size and the box types. So for the box size, you have now intrinsic, which is the content is determined whether the space is occupied, or restricted, and that is so the content of that box is governed by a set of rules. So whether it is you explicitly tell the width and the height, all right, or other constraints like from the pattern, another constraints like from the patterns or other box, like you tell now the flex box. For example, here, intrinsic and restricted. Okay, so intrinsic, it means that the box is used in its contents to determine the space it occupies, the width and the height. All right, this is intrinsic. And the other property is of this box size is restricted. Is that, hey, this indicates that the box size is governed by a set of rules applied to it. And this can be is, or this set of rule, or this restrict box size is a set of rule that you explicitly tell to the box, such as the width and height via CSS, or the constraint by pattern elements and other boxes through mechanisms like flex or grid. So you have now this a layout system. You perhaps the pattern is now providing you is a percentage, the percentage of the pattern side, the aspect ratio property of image, Okay, again, this is a way to determine is the size makes a lot of sense based on that constraints, the aspect ratio, and the other is the presence of other children in the DOM tree. So this is now how you can alter the size, which is one of the property of this box. Okay, whether it's intrinsic or extrinsic. And extrinsic or restricted is a set of rules that you apply. That is a set of rules that govern this box that I apply to, whether it's the width and height via CSS, or the percentage of the pattern content, or the aspect ratio property of an image, or the presence of children nodes, or the presence of children nodes in the DOM tree, right? So for the box type is, well, pretty much descriptive. We actually know what it is. You have now the inline, the block, and the anonymous. And anonymous is just the way of when you don't tell the browser, when you don't explicitly indicate when you don't use an HTML tab to wrap content. So the browser actually put a context, an anonymous box around that content, right? But what is relevant for this is that you have now from this box is type a block or inline, and in the block, well, all of the elements. So the element is rendering in a block. It means that it will take 100% of the width available. Okay, it means that you're gonna take 100% of the width available from the padding container width. Okay, and the height is determined by its intrinsic value. In other words, by the height of that content. This is a block, and the normal flow here, or the elements, is rendered from top to bottom, and it participates in something called the block context formatting. So this is something important, especially if you're gonna use a type of box, if you're gonna use a box of type block. And there are several examples here, because you have now all of these HTML elements, address, the figure, cap, header, not script, table, articles, div, all of the main, nav, all of these are boxes. So when you put that HTML tag, the browser treat that tag as a box type block, and then you may wonder, okay, yeah, what does it matter? Why do I care about this type? Why do I care about this HTML tag? The browser treat that as a type block, right? And actually, well, it's gonna take all of this. So this is the content itself. So it takes all of the 100% space and the height and that kind of thing. So why this is relevant? You might wonder. We're gonna see about that, and also the mathematics of the block elements as well. That's why, for example, here we use for box sizing as a way to tell is, hey, let's gonna use the border box to save us some computations there. And when it comes to the inline elements, I'm gonna explain why we need to actually take a look at the box type, as well as the box type and the inline tab, as a way to make sense of what we're going to do. So unlike a box type, block, inline elements, which is our particularly HTML tags that the browser, when they see that, it's gonna treat them as an inline element by default. In other words, is they render as a string, as a sequence of elements, right next, one next to it, from left to right. And when they reach to the bottom, from top to bottom, Okay, and they participate now in something called the inline formatting context. So they generate inline levels. So why this is important? As a way to also understand that this particular box or the inline elements here, when it comes to the mathematics, the width and height cannot be modified. Okay. Yeah, so the width and height cannot be modified. It completely ignores those properties, the width and the height, similar to the vertical margin, and the padding does not alter is the height of the content. Again, why this is important? Why we're looking at the box as well as its property, like for the size and for the types. Okay, as a way to now understand this thing called context or formatting context that we talk about is a lot. We so far talk about is the block formatting context, the inline formatting context, as well as the other formatting context like flex and grid. Okay, but the idea here of this formatting context, okay, is that it provides now an isolation of all of these elements, inline or block or flex or grid. It is scalable because if we follow the rules, the elements, exactly, introducing a new rule set, for example, is as simple as creating a new context. It is scalable, okay, and also it is predictable. So yeah, it is. So the idea of formatting context is that you have now is all of these different contexts that are now isolated, so the browser can isolate that. It is scalable because you can use that, and by using this new rule set, by using this formatting context, we can now is depending of which formatting context you want to use, block, inline, flex, we can add more to that. It's scalable, and the other is that it is predictable because you once you know the rules, you know how the element is gonna be placed. One. So once we know how the element is gonna be placed here, that's why we look now at the a couple example here as a way to see that how the block formatting context works. At the HTML actually create now a block formatting context by default. Okay, and then how you can now, as you tell or as you write all of these HTML tags, now you are telling to the browser how it must treat each one of those elements. So whether it's using a span, well, you are defining now as inline elements, for example, here, like so, which is exactly is now how we did here. As a way to understand is like, hey, that once the browser that see this is say, hey, this is a block, all right. The body doesn't have any special formatting context, but the H1 it does, and that is a block. So it put that is a block similar to the URL, which it create now a block as well. Lee actually is create now a block type as well, but in this case we are telling to the browser, hey, I want you to now make these elements inline, similar for this one. All right, so now it's going to create now a formatting context where all of the elements inside of that will be rendered as a string from left to right. Okay, and then top to bottom. So P actually is going to be rendered as an inline element, I think it is, or as a block. And when you reach to this HTML tag, you say, hey, okay, now by default I'm gonna treat this as a block, but since in the style or via CSS we change the formatting context via flex, by putting is now a flex. All right, now I'm going to treat all of the elements inside of this follow the guidelines of flex. All right, in this case you say, hey, the flex direction is rho, so because by default it follows the inline context where it put all of these elements next to another in the flex. By telling is you say, hey, I want you to now is putting all of this as a row, okay, or one after another. And here, when it reached to the span, you say, hey, now this, let me treat that as an inline block element. So the idea of all of this is to see how now the browser is starting to treat all of these elements. And you may wonder why this is important. So now that why we care about is the box model, the box anatomy, the box properties, the size, and it is type, as well as in the size you have now intrinsic and restricted, and also is the type of box, and how you have now inline, block, and anonymous, and how the block and inline now have or participate in something called the formatting context, block or inline formatting context, and how now what are the mathematics behind the block and inline, as well as there is a special properties here, and how by understanding now this formatting context, which is something useful for the browser as a way to now isolate all of these elements, as well as it is scalable, because once you now have this formatting context, no matter which value you are using, it's going to follow a particular rules, whether it's block or inline or flex, which makes them predictable, because we know how the thing is going to be, how the browser is going to position all of our element here. And because we're talking about positioning, that's what we see about is the browser positioning system. So the browser now is the normal flow of the context, okay? Where this is now putting all of the content from you, depend of how you're going to tell how you're gonna position all of these elements on the browser. You're gonna tell it like, hey, please do this from left to right or right to left, okay? And it's going to put all of these elements as it is. And once you change now the browser positioning via a position property, okay, by default it is static. Okay, by default it is static. But once you change now a particular element, therefore a particular formatting context from its normal flow via position CSS property with the absolute and with relative and absolute or sticky or fixed, what happened is that because by default it follows the position static, it's like, hey, put this box here and all of this box here and that kind of thing. It actually render all of that one after another, okay? If you break or if you change, not break, if you change the normal flow of the position of the element, okay, so the element is positioned according to the normal flow of the document. So you have now the offset applied relative to itself based on the values of top, right, bottom, and left. That's one of them. Okay, so element is positioned according to the normal flow of the document. Okay, an offset applies relative to an offset. Okay, this is position relative, exactly. So the element position according to the normal flow of the document when you use position relative, right? So the offsets apply to itself based on the value to top, right, bottom, and left. And the offset does not affect the position of any other element on the space allocated for that. Thus, the space allocated for the elements in the page layout remains the same as if the position were static. But what happened is that we change the normal flow from this component, okay? Essentially creating a stacking context. This value created a stacking context when the value of C index is not outer. This is now the position relative as well as the position. And before moving to that, we need to look at the containing block couple things. Why? Because this is the way how now the browser, by using as a position relative, anchor is elements to that, elements to this stacking context. In this case, to this new formatting context that you're creating by changing the normal flow via position CSS property. When you put now relative or absolute or fixed, okay? So all of the elements inside of that, okay? And in this case, when you're using now the position relative, it's gonna serve as the anchor of all of the elements that you define inside of it, as well as creating is a new stacking context. This stacking context is part of the way how the browser is positioning its elements, which is great, okay? And when you use now position absolute on a particular element, it's gonna look at what is the container element that, whether is they use now as the position relative or the closest, okay, or the closest, it is position relative to its closest position ancestor. If one exists, otherwise it is placed relative to the initial contain block, right? So it is going to put that, or when you're using position absolute, hey, I'm going to put this element to its closest position relative pattern or to initial containing block. So the position of these elements is determined by top right, bottom left. Okay. The element is removed from the normal flow, so there is no space is reserved for the elements in the page layout, and this positioning is a stacking context as well. Why this is important? With position relative, we're telling the browser, hey, these elements will be position reference for all the child components. Exactly. This is the containing block for all the child components, or for all the child elements here, which means now the browser create a stacking context, right? If you're using, for example, this position relative. If you're using that position absolute, you're telling us that, hey, to the browser, this component, we're gonna change the normal flow, we're gonna be outside of the normal flow, and it's going to look at the most closest position pattern element or the initial block element for that. So once you do this, right? So here you are creating is now you have the normal flow. You create now a layer here where this will be is the container block for all of these elements, as well as you create now two reference to the containing block, to the relative here, using the absolute. Okay. So the TLDR of all of this is to see the importance of these two type of position, relative and absolute, lies in their ability to remove items from the normal flow. And the idea here of looking at the browser position systems as a way to see how all of the elements is gonna render, and when you change the normal flow, you tell the browser to now change is the way how all of these elements we're gonna render. Therefore, it's gonna create a context, a stacking context, as long as you provide is a position or relative or absolute for this particular case, where the idea here is that now the browser know that this particularly stacking context is isolated, which means that it's not going to affect all of the other elements outside of this, and I can do some optimizations of this. And I can do some optimizations like this. So optimizations like when you're using now the stacking context with properties, with 3D transformation, all right? So when we build layer, we work only with X and Y axis, meaning that everything is in place in a single layer. However, when we engage in any 3D transformation, absolute position, or anything, or any action that moves the elements out of the normal flow, we activate is an stacking context, right? And it is funny because absolute positioning is now engaged, as well as 3D transformation is now putting these elements and all the child elements outside of the normal context. Okay. Exactly. Outside of the normal context. Yeah, we activate an additional axis known as it putting out outside of the normal flow, therefore creating a stacking context, which by creating this stacking context, the browser now can isolate all of the elements in there, so they're not going to be affected, as well as it can create some performance optimizations. Okay. So elements removed from the normal flow are placed into a new stacking context. Modification to every element within a separate stacking context do not impact any other element within the normal flow. Okay. Modifications to every element within a separate stacking context Modifications to every element within a separate stacking context do not impact any other element within the normal flow. All CSS transformations are GPU accelerated, meaning that the browser don't need to recalculate the DOM tree when such operations are performed. And I think this is something important here. So when you're using now 3D transformation, all CSS transformations are GPU accelerated. Not all of them, or I mean yes, but some of them involve is so the browser doesn't need to recalculate the DOM tree when such operations are performed, and this minimizes the reflow cycle. Which means that by minimizing this reflow cycle, which is the way of how the browser needs to recalculate is the DOM element, and the reflow is just this process and how now the renders or how now is the browsers paints these particular components. So it's when they transform the HTML and the CSS into the DOM and the CSS object model. They merge into the render tree and then pass that with all of the information needed to the reflow process. That's quite interesting. And the reflow process is the way that after so the reflow is interesting. So the reflow process is part of the critical rendering path. I'm not sure if this still exists. the critical rendering path. Okay, the render tree and the layout. That's quite interesting. That's quite interesting. So yeah, so this image is the critical rendering page, critical rendering path. So reflow is one of the components over the entire assembly line here. Oh my god, an assembly line has a very powerful stuff, and I know why. Yes. And I know why people, Aldous Huxley thought that Happy World will be a very, 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 very real thing. Because the power of assembly lines, and this is also part of the concept from the mathematics, but the power of assembly lines for everything as a way to get an output. The power of assembly line for everything. Okay. So reflow is part of the components over the entire critical rendering path. And then you have now the repaint. But it's on the reflow that is part of the critical rendering path, which is the way of how you transform HTML, CSS, and JavaScript elements into into elements into pixel on the screen. So it creates now this DOM, the CSS object model, and they merge that into the render tree. Now it contains all the necessary information to pass down to the reflow, where this step is where it's going to calculate is the geometry and the position of the elements in the browser. Oh my god. And this is usually triggered by JavaScript here, where now if you modify a style here, it's going to now pass through the layout, all right, as a way to now calculate is the position of all of these elements that you modify through JavaScript usually. Now the browser knows what is that, then it's going to paint that. Because Reflow is a user blocking operation in the browser, it is important to understand how to redoes it. So for example, when a React app the initial render of the DOM, then you provide the container when React will mount the app and do some modifications to the DOM via the DOM API when the state change. So the reflow is a multi-step process, and in reflow is a user blocking operation for the in the browser, and it's important to understand how to redoes this. So for example, when a React app the initial render of the DOM, then you provide a container when the React will mount the app and do some modifications to the DOM via the DOM API when the state change. So the reflow is a multi-step process, and is usually kicked off by GSS. Then the browser need to recalculate is a DOM and the CSS object model here to generate is a render tree, okay, which is here, which is part of this style, and where it needs to know the position of the HTML elements, attributes, and geometry, the layout. The style and layout is very intense CPU operation. So if we trigger too much reflow, it will slow down our app, which means that if for some reason we are constantly manipulating is the DOM elements on the screen, all right, or we changing is the geometry, or there is also a particular website that actually tells you what to do and what actually trigger a reflow. Okay, because those operations are CPU intense. Okay, aka they wanna block the main thread, they're gonna block the render thread. Once everything is ready, we need to draw the bitmap on the screen. Paint, which is the GPU use, it doesn't use CPU, which make this pretty fast. So the idea here is that if this is a video that showing how the browser is rendering the Wikipedia, which is something here, the reflow, again, this is part of the critical rendering path. Okay, and then you get the initial pipeline, JavaScript style and layout, and the optimized pipeline as a way to prevent to trigger is the reflow state, or as a way to prevent is the trigger the layout. And the difference is small. In the 4 lines of code are massive difference, because one of them is you are altering is the geometry of the element as well as its position, and the other is that using is transform to do that. And transform actually is using is the painting composing. It's actually use the GPU instead of calculating its elements for that. And I think that's quite very interesting as a way to understand all of that. So yeah, that'll be all for this video. Take care. Bye bye.